All right, let's get started with the webinar. We still have some folks joining, but they're going to miss out on some of the introductions, but I think they'll be ready for the session once we get into the meat of it. So we'll get started with meat of the presentation. Thanks, everybody, for joining me today. I appreciate it tremendously. This month's Celestix monthly webinar is on the topic of high availability for direct access. So before we get into the heart of the conversation, do a little bit of a brief introduction for those of you who may be new to Celestix or maybe don't know who I am. My name is Richard Hicks, and I'm the Director of Technical Services for Celestix Networks. And I'm a Microsoft Most Valuable Professional, or Microsoft MVP in the Enterprise Security discipline. I have a variety of your compulsory Microsoft certifications. Been in the IT field for a number of years, almost 20 years now. The majority of that time spent as a network and information security expert, primarily working with Microsoft Edge Security and Remote Access Solutions. So I've been doing the Microsoft Security Solution stack for quite some time, many years. Celestix Networks has been around quite some time as well. Celestix began life in 1999, so quite a few years ago. A security company originally started out building checkpoint firewalls. So they were originally a checkpoint OEM hardware provider, developing some solutions based on checkpoint software from way back in the day. Had many OEM security partner relationships with companies like Surf Control, WebSense, Vercom, RSA, BMC. There's a variety of companies that we've built their hardware solutions for that you probably know and recognize, and even probably used our solutions and perhaps didn't even know it. Celestix has a worldwide presence. We have offices here in the U.S. as well as Europe, the United Kingdom, Asia Pacific region as well. We have a countless number of customers across just about every vertical you can imagine, and our solutions are available through probably your very favorite partners and resellers in your region. So our solutions are quite accessible, so you shouldn't have any trouble finding us or finding our solution set either. So again, today we're going to talk about high availability options for direct access, specifically Windows Server 2012 R2 direct access. So if you are running direct access on UAG, keep in mind that all of the conversation today will be aimed at the latest release of direct access, that being Windows Server 2012 R2. We're going to cover direct access high availability from a couple of different aspects, but the main goal of providing any high availability solution or making any solution highly available is to find and eliminate any single points of failure, because those are where the real challenge spots become. And during this particular session, we're going to approach that from the hardware level, the direct access server level. We're also going to talk about providing high availability for a very critical service to direct access, and that is the network location server. We'll talk a little bit about that later, about some of the challenges that the network location server poses. And then finally, we'll wrap up the conversation with a discussion about data center redundancy and some of the options that are available in Windows Server 2012 R2, and more importantly, some of the limitations that you perhaps may not be aware of. So at the hardware level, of course, when you're deploying when you're deploying direct access, of course, we highly encourage you to do that on the Celestix Advanced Hardware Appliance platform. I may be somewhat biased here, but at the end of the day, we do have an excellent hardware solution that I think is extremely compelling. We have a variety of different models. Of course, we have kind of a small, medium, large arrangement, the E3400, 6400, and 8400 series appliances in our E Series range. They come with a variety of different CPU flavors and memory configurations and different disk redundancy options as well. And I want to dive into each one of those kind of very quickly here and point out some of the unique features of each of these. So the 3400 series is our small, in the small, medium, large range. And the E3400 is a fantastic little unit that actually doesn't have any hardware redundancy at all. Now, you might be asking yourself, or maybe asking me, hey, why are we having a conversation about high availability, and then the first appliance you show me has no hardware redundancy? Well, the truth is, it's actually by design. This unit was targeted at the small and mid-sized business market. It's an excellent unit for very small deployments. We use it commonly for proof of concepts. We could drop one of these out very quickly, get it up and running, demonstrate direct access, test some applications and make sure it works, and then we can ship you full-on hardcore enterprise data center hardware to do your actual data center rollout or whatever. The bottom line is again, it's a small unit, extremely compact appliance form factor. It's one rack unit. It's standard 19-inch, of course, and it's half depth, not much bigger than a Cisco Catalyst like 48-port switch. So it's not much bigger, not much heavier than that. It does have an enterprise play, however, because it can be used in scale-out scenarios, and I am personally a big fan of the scale-out model as opposed to doing the scale-up. And the reason for that, and again, in the context of our conversation today about high availability for direct access, is that this low-end unit, the 3400, can actually be deployed in clustered pairs, and then we get redundancy basically at the hardware level or at the appliance level. If I lose an appliance, I still have redundancy in the solution, and I still have plenty of capacity. One of the significant advantages to a scale-out deployment such as this is if, for the sake of argument, let's say 2 of our 6400s would handle the capacity of my target audience. I'm going to support X amount of users. 2 6400s would work. If, for example, I were to deploy 5 3400s, if I lose a device, I still have, again, I don't have any redundancy in the box, but I have redundancy at the appliance level. And so if I take a box offline for servicing, maintenance, patching, what have you, perhaps perhaps the PDU that it was plugged into failed, or the switch that it was plugged into it failed, or something like that, I lose that device. What you'll notice is that I lose just 1 out of 5, so I'm losing only 20% of my capacity. If you contrast that with a scale-out scenario, which is often deployed in an active-active clustered pair, where if a unit is offline for any reason, whether that's planned or unplanned, I lose half of my capacity, and when I am lost half of my capacity, I now have no redundancy, so if I lose the second unit, I have no service. Here I can actually afford to use another unit. I could even use one more, still have full redundancy built into the solution. So I'm a big fan of the scale out, something I would encourage you to consider for large deployments. Of course, the challenge to this, and one that is a pushback for customers when I'm talking to my enterprise customers, is that in terms of management, I have to manage 5 devices instead of 2. I get that. If you choose that route, we still have plenty of options for you. So the 6400 and 8400 appliances are kind of bread and butter. These are beefcake units, I should say. The 6400s are mid-range device. This is probably our most popular model. Price performance on this is fantastic. And has full hardware redundancy as well. So does the 8400. The 8400s are enterprise, kind of a data center unit. This one's like massively scalable. Supports has full RAID 5 disk drive arrays. It has maximum port density. I think it'll support up to 32 gig Ethernet ports. It does support 10 gig E, so it has all kinds of flexibility like that. So very powerful unit. And both of these units fully redundant in terms of disk drives, power supplies, cooling fans, and whatnot. And again, these units are designed for maximum performance and scale-up deployments. Typically, you'll see these deployed in clustered pairs, active, always. And then, of course, they can scale farther than that if you need to. But they have plenty of hardware capacity to meet the demands of just about any enterprise you can think of. So let's talk briefly about the DirectAccess server and some of our load balancing and failover options that we have for the DirectAccess server, and maybe more accurately, the DirectAccess service, right? So the DirectAccess role running on the appliance. So we have a couple of options for load balancing and failover, and the first is the tried and true integrated load balancing. You may be familiar with Windows Network Load Balancing. Excuse me. For those customers who may be familiar with ISA server, and IAG or TMG and UAG, you're probably familiar with network load balancing. It was a way to create clusters in TMG and UAG. ISA and IAG, you can do the same thing with DirectAccess. You can create a clustered pair using Windows Network Load Balancing and have active load balancing and failover. The advantage to Windows NOB is that it's easy and it works almost without fail. The real challenge and one of the disadvantages to using integrated network load balancing is that it's noisy. It's noisy on the wire. It's broadcast based. There are broadcast messages that go out from each node in the cluster one time every second. So once a second there is a broadcast message. If some of the ways that, and of course this gets to be real noisy on the network, as I had stated. Sometimes the network folks don't like that because all stations in the broadcast domain, of course, are going to hear this traffic. And the way to work around that is, of course, to design your VLANs in such a way that the interfaces for the DirectAccess server or any network load balance, any device using network load balancing should be placed in an isolated subnet, right? Dedicated VLAN. That way, the broadcast traffic is basically isolated to that subnet. So that's a way to work around that. You do have the option to use an external load balancer, and there are a number of third-party load balancers in the world, both physical and virtual, that provide very capable load balancing services. The advantage here is that you have better load distribution, you have much more granular and intelligent traffic management. A lot of these are full-blown application delivery controllers for which you can do advanced things like offload SSL, and do some other things as well. So there's some great capabilities there. Of course, the disadvantages to using a third-party load balancer or an external load balancer is that it does add costs and complexity. Maybe it makes it a little more difficult to troubleshoot in some scenarios. But at the end of the day, if you have those services or if you have those skills or you want to take on those costs and trade those for those better features, it's certainly fully supported and supported by Microsoft and Celestix as well. Quick word about manage out, though. So manage out scenario, if you're familiar with that, that's where a client or a host on the internal corporate network can initiate outbound connections to a connected direct access client. Extremely powerful deployment scenario, and one that we see quite common. The challenge with manage out is that it is not supported with external load balancers. So when you configure an external load balancer, you do lose that feature, so keep that in mind. The reason for that is that when the direct access server is installed, it configures itself as an ISA-TAP router. If you use an external load balancer, then effectively the direct access server loses that capability. I would say if your load balancer can function as an ISA-TAP router, you may be able to make something work like that. But the formal guidance from Microsoft is that if you use an external load balancer, manage out's not supported. If you need manage out capabilities in that instance, then you will have to deploy IPv6. So let's talk briefly about the network location server. So the network location server is a very critical service. If you are a current direct access administrator and if you've ever had any issues with your network location server, you're probably going to know exactly what I'm talking about here. But for those of you who don't, just a kind of a brief overview. The network location server is nothing more than a web server on your network with an SSL certificate that the client uses for inside-outside detection. It is a service that is only reachable from the CorpNet. You cannot reach it on the public internet, and it is not accessible over the direct access tunnels. The client uses this almost as kind of a lighthouse or a beacon to know that it's on the internal CorpNet. So when there is a change in network interface status, so whether the when a network interface comes up, the first thing it will do is go out and look for the network location server. If it can establish a connection to it, then the client believes to be on the CorpNet. If it cannot establish a connection to the network location server, it believes it is outside of the corporate network and will then try to communicate to the direct access server to get back to the CorpNet. The problem is that if the network location server is not available, your internal clients actually get cut off. And the reason for that is because if they think they're outside, they start to try and communicate with the direct access server. And one of two scenarios will happen here. And the most common is that it actually can't get to the DA server from the CorpNet, and it also at the same time cannot talk to the internal CorpNet because it thinks the only way to get to the CorpNet is through the DA server. You have this real catch-22, right? You can see there's this pickle here. And so the bottom line is that it puts your internal clients, your direct access clients, when they're on the CorpNet in a state where they're basically orphaned. They're cut off. They really can't do anything until the network location server comes back online, or there's some other ways around that, and if you want particular details on that, I can help you. There's also a hotfix for, I think, for Windows 8 clients that helps alleviate some of that pain. But the bottom line is, and really in the vein of our conversation today, is we need to provide some failover so that we don't run into that scenario. So ideally, we want to provide some level of load balancing for the network location server. And here we have the same options. We can use Windows MLB. We can use an external hardware or virtual third-party load balancer. The bottom line is that we want to make sure that when we build the network location service that we don't have that single point of failure. I urge my customers, when you're building one, build two, enable NLB. It'll be the best day of your life because you just save yourself a lot of pain. If one goes offline for whatever reason, and again, a lot of times folks don't take this into consideration, is that these boxes have to come offline for updating. They have to come offline for servicing. There's patches that get installed that require reboots. There are going to be times when the network location server, by design and purposely, is going to be offline, and it could cause some pain. Now, of course, I know, coming from the enterprise, we have outage windows, and those are usually at ridiculous times. But we live in a globally connected world. There's probably going to be people in the office at some point during an outage window who you can impact. And more importantly, this happened to me not long ago. I was working with a customer who was doing this. They themselves got cut off because they were doing the management from a DirectAccess client, and when they restarted their network location server, they basically got kicked off the network. So they had to wait for the service to come back. Eventually it takes care of itself, but bottom line is that's a planned outage, and there's still some pain. Unplanned outages cause a significant amount of pain. You can also leverage a GSLB solution or a global server load balancing solution to provide intelligent traffic distribution for your network location server. This is common. This is probably more common and more frequent for large enterprise scenarios where you might have multiple physical locations. Let's take for example, I had a large organization, large business that had an office in Los Angeles, another one in Dallas, and another one in New York. I might, in this scenario, build one network location server in Los Angeles data center, another one in the Dallas center, and another one in the New York data center. In each of those locations, I don't necessarily have any redundancy, so I have that single point of failure, but I can leverage a GSLB solution to say, use one FQDN for that, nls.corp.example.com, and then use the GSLB to return the IP address of the closest network location server to the client, and if that server is offline, then return another one from the next closest data center. So there is an option to use GSLB internally. If you have that service, that might be an efficient way to kind of distribute some of that traffic. The last option really isn't an option at all, and that is using round-robin DNS. I've had a number of customers ask me about this. Can I just use round-robin DNS, create 3 A records, put 3 web servers up, and then use those? The answer is no, it's not recommended, it's not supported, and the reason for that is because of a client. If round-robin DNS were configured for the NLS FQDN and the client made a request for made the name resolution request, got the first IP address back from the query, and tried to connect to it, and it was offline, it would then immediately think it was outside the corporate network, and it would just cut itself off. So you have, it doesn't really do much for you. It's still going to cause problems. You're better off just using NLB or some sort of other load balancing solution. Don't use DNS round robin. It's not going to work. You're not going to be happy with it. It's just going to cause more problems than it solves. So finally, we'll talk about the data center. So and this is mostly targeted at large enterprises that have multiple physical locations. But Windows Server 2012 R2 does provide geographic redundancy. We have the capability in Server 2012 R2 DirectAccess to create a single deployment and use multiple entry points. So this is something that's very different if you have any experience with previous versions of DirectAccess. If you were using DirectAccess as a part of Server 2008 R2, you were very brave. If you were more commonly using it with UAG, you know that you can only set it up in one location. If you want to set it up in another location, it effectively becomes just a parallel installation of DirectAccess. Here with Server 2012 R2, again, you have a single deployment, you have multiple entry points, you can manage it from a single pane of glass. Same management console, you can effectively manage and monitor all of your entry points in the organization. So this is important because I can deploy DirectAccess, and I have 3 data centers, so I could put a DirectAccess server in Los Angeles, I could put one in Dallas, and I could put one in New York. And of course, there's nothing that prevents me from from implementing high availability in each of those scenarios as well. So I might have a clustered pair in Los Angeles, a clustered pair in Dallas, and a clustered pair in New York as well. So I can do, these aren't mutually exclusive, and there probably are some compelling reasons to do that as well. The challenge, of course, is that, and one of the pain points that this addresses is that I can have all sorts of, I could have 10 direct access servers online in Los Angeles, but if my ISP goes down, it doesn't do me any good, right? That traffic's not going to be able to get to my data center, so I want to fail over to another data center, and that's where direct access multisite comes in. With direct access multisite, you can configure your clients to perform automatic site selection and transparent failover. So that means that if I am in Southern California and I'm outside of the office and I open up my laptop and log onto the network, then as soon as I have an internet connection, my direct access client will then go out. It is, of course, aware of all the entry points in the organization. It makes some probes, and it determines which site is closest, and it connects to that. If that site is not available, then it will connect to the next available entry point. If the site becomes unavailable during my session, so I'm already established a connection to LA, and LA's ISP goes down, it will then detect that, and it will transparently fail over to another entry point. So extremely powerful and flexible solution, and very welcome, especially for our large enterprise customers. Now, it does also support global server load balancing, so you can use your GSLB solution again to provide a more intelligent traffic distribution, have more granularity. It also provides, in my experience, a more accurate and effective means of closest site detection. So when a Windows 8 client detects, makes an attempt to detect which site is closest, it basically does that via round trip time. It sends an HTTP GET to, let's say, those three sites, Los Angeles, Dallas, and New York. Sends an HTTP GET to each of those data centers. They all come back. It chooses the one with the quickest round trip time. That may or may not always be the closest entry point, and I've worked with many customers who've had some challenges with that. Hey, I'm in Minneapolis, but for some reason it keeps wanting to connect to Los Angeles and not, New York or Chicago or something like that. So there are a number of different factors that can influence round trip time, and so it's probably not the best method to do that. And again, if you have a GSLB solution, they have much more intelligent monitoring and capabilities to determine, which data center to send those to. So those are always great to use in for large deployments. Now, I want to leave you on a bombshell here, and of course, this is the news that nobody wants to hear. Is that all of the geographic redundancy options that we've been talking about to this point, just on this slide, not everything else, just this slide, are only available for Windows 8 clients. So geographic redundancy is not supported on Windows 7. Windows 7 clients can only be configured to use a single site. So in my scenario with LA, Dallas, and New York, if I have a direct access client that I assign to the LA entry point, if it goes to Dallas, if it goes to Chicago, if it goes to New York, it will always connect to Los Angeles. If the Los Angeles site goes offline, that client's not, it can't access the CorpNet. Even though there's two entry points remaining online, that client cannot connect. And the reason for this is a fundamental limitation in the way IPsec connection rules are configured in the Windows 7 client. And so the challenge there, of course, is that to get these geographic redundancy capabilities, you must be running Windows 8 or later. So if you have Windows 7 clients or you're supporting a lot of Windows 7 clients, understand that the single deployment, multi-entry points, automatic site selection, and transparent failover are not supported for Windows 7 clients. Global server load balancing is not supported for direct access clients running Windows 7 either. So unfortunately, I'm just the bearer of bad news. Don't shoot the messenger. But many customers find this out too late. They've deployed this and they want to take advantage of it and think that Windows 7 clients will support that. Unfortunately, they cannot. So on that, I will proceed to questions. I expect I'll have a few probably on that Windows 7 probably on that Windows 7 question, but if you have questions at all, go ahead and put those into the question window, and I will do my best to answer those for you. Okay, so the first question is Windows 7 client support. What happens when the DirectAccess client, Windows 7 DirectAccess client, connects to an entry point that's not available? So again, it will not connect. So in my scenario, as I described before, you have a Windows 7 DirectAccess client. It is assigned to the Los Angeles data center, and that data center is not available for whatever reason. It will not connect. Doesn't even know about the Dallas or the New York data center. It only knows about the LA data center. And if it's offline, it's done. It can't connect. It will not reconnect until that data center comes back online. Now, it is possible to rehome that client to a new data center. So, for example, if the data center was online and I wanted to plan an outage to take the DirectAccess servers offline in Los Angeles, I could move them over to the Dallas data center. And the way I would do that is I would actually move their group membership from the security group for the LA data center and move them into the security group for the Dallas data center. I have to wait a period of time because, again, the group membership, when group membership changes, group policy doesn't, or the group membership doesn't change for quite a period of time, 8, 10 hours, or I forget whatever that is, or if the client reboots. So I have to wait a period of time. So I can't just move them into that group, wait 5 minutes, and then shut down that data center. I will lose all those people. If it's an unplanned outage, if it goes down and all those clients are connected and I do need to swing them, so in other words, perhaps this is going to be a long-term outage and they need access to another data center, I can move them, I can go into AD and move them into the security group for the new data center. The only challenge that we face there is that the client must update group policy. Well, it has to restart one, so it has to update its Kerberos tickets to get the new group membership, and then update group policy to get the new settings for the second data center. The challenge there is without direct access, it has no access to the corporate data center. So again, you're in a pickle. It's catch-22. So there you can use an existing client-based VPN solution if you wanted to do that. So if you have an existing VPN solution, Cisco Checkpoint, Juniper, Sonic Wall, what have you, keep in mind that you can deploy direct access with client-based VPN at the same time, so you can actually leverage our solution to do both. Might not be a bad idea in case of those disaster scenarios where you have a huge failure and you can't recover quickly. But in those cases, you can move the security group, have the client reboot, have them connect out of band, so using client-based VPN, update group policy. They will pick up the new settings for the new data center, and then once they terminate their VPN connection again, boom, they'll connect to the other data center. Your Windows 8 and later clients, however, don't have that pain. They will be able to transparently failover. Let's see, next question. Can I explain the IPv6 requirements? So, Jim, there are no IPv6 requirements. We did, so I think last month's webinar, or I think it was last month, it was a couple of weeks ago, I thought. I did a webinar, and you look for it on the Celestix website, where I talked about the myths, some of the common myths associated with direct access. And I spoke, I think IPv6 might have been one of the first ones. There are no IPv6 requirements. So IPv6 is not required for you to deploy on your CorpNet. You don't have to be on the IPv6 internet anywhere. You're good to go. You don't have to know, you don't even have to know how to spell IPv6, for God's sake, to be able to install and configure it. I will share with you that DirectAccess does use IPv6 exclusively for transport from the client to the DirectAccess server. And if you plan on doing any troubleshooting, you're going to have some IPv6 working knowledge. So, but to install and configure it, you can do it. You can do without it. You don't really have to have IPv6 deployed on your intranet anywhere. And what makes that possible are the DNS 6-4 and NAT 6-4 services running on the DirectAccess server that translate the clients, the DirectAccess clients' IPv6 traffic to IPv4 so it can talk to your CorpNet. So I would encourage you to jump out or to take a look at that that webinar. It's posted on the Celestix website somewhere. Anyway, I spoke at length in there and talked about some scenarios, so you can check that out and probably learn a little bit more. There may also be some information if you go to my website. If you go to directaccess.richardhicks.com, you might find some information there as well. You can just search IPv6. I'm sure you'll find something. Okay, so next question, similar to the one I said before, Windows 7 clients, could I potentially change the connection configuration live? So yes, you can. The challenge that you face is twofold. One, when you change a security group for a client or user, you have to reboot to pick up those new permissions. Two, the client has to be connected to the corp net in order to refresh group policy. And with the DirectAccess server down, there's no way to do that unless you use out-of-band a VPN. Very good. Looks like that's all the questions. We've run a little bit over our time, but not too much. If you have any other additional questions, don't hesitate to reach out to me. You can drop a note to sales@celestix.com. Tell them you have questions. They'll forward your email to me. If you have questions about any of our offerings, products, or solutions, drop a note to sales@celestix.com. And then, of course, if you're interested in knowing any more about our advanced hardware appliance platform, take a look at celestix.com/edge and check those out. And you should, if you have any other questions, like I said, reach out to the sales folks. They'll put you in touch with me, and I'd be happy to answer any of the questions you have offline. Thanks, everybody, for joining the session today. I appreciate it. We'll talk again soon. Take care. Have a good day.